Section 5.2 tells us how to find integrals involving logarithmic functions. Now, before we get the formula for integrals involving logarithms, let me first give you a little bit of theory as a warm-up. So here's a warm-up question. What is the derivative with respect to x of the absolute value of x? Sorry, the derivative with respect to x of natural log of the absolute value of x. Well, remember that the absolute value of x is equal to x if x is positive, and is the opposite of x if x is negative. I'm not going to worry about the case that x equals 0 because natural log of 0 is not defined. So let's look at the two cases. Case 1 will be when x is positive, and case 2 is when x is negative. So in case 1, the derivative with respect to x of natural log of absolute value of x. If x is positive, then the absolute value of x is just x. So this is the derivative with respect to x of natural log of x. And we learned that that was equal to 1 over x. Now let's look at case 2. Let's see what happens when you take the derivative with respect to x of natural log of absolute value of x when x is a negative number. Well, if x is a negative number, then the absolute value of x is the opposite of x. So if I want to differentiate this, I need to use the chain rule. So I'll get 1 over negative x times the derivative of the inside, which is negative 1. Remember, the derivative of log u is u prime over u. Well, look at that. That gives you 1 over x also. So natural log of the absolute value of x has domain all numbers except for 0. And if x is positive, its derivative is 1 over x. And if x is negative, its derivative is 1 over x also. So our conclusion is, as long as x is not equal to 0, the derivative with respect to x of natural log of the absolute value of x is 1 over x. Well, that's what motivates our integration formula. If the derivative of log of absolute value of x is 1 over x, then that means that the antiderivative of 1 over x dx is natural log absolute value x plus c. So that's going to be our first integration formula involving logarithms. Now for the u subversion, I can just rewrite this with u's. Integral of 1 over u du is natural log absolute value of u plus c. But there are also some other forms that you might see this in. One is when you just simply see the du written on top. Instead of writing 1 over u du, you sometimes see integral du over u. That doesn't change anything. And another one is sometimes that u is brought up to the numerator with a negative exponent. So sometimes you see this written as the integral of u to the negative 1 du is natural log absolute value u plus c. And notice that this takes care of that one exception to the power rule. Where the power rule says that the integral of u to the n du is 1 over n plus 1, u to the n plus 1, plus c, provided n is not equal to negative 1. If you're to try plugging negative 1 in, or sorry, n equals negative 1 into this formula, you get a 0 in the denominator. So the power rule doesn't work when n equals negative 1. This formula works instead.